University of Cambridge and others in the NHS, National Health Services. And maybe I won the title for, I won the prize for the longest title. I don't know, maybe there's a longer later, but is Healthcare Process and Variable Mapping for Identifying Digitalization Opportunities and Building a Hospital Digital Twin. Right, so first of all, a little bit of background on the digital twin concept, but I don't think that we actually need it because we have seen many, many other presentations on the similar things. There are several conceptualization of digital twin in literature. In this room, many people have been, are currently actively working on that. What we're interested in is the middle layer. So it's what we can produce through an exchange between the physical and digital, data exchange between the physical and digital asset, which will give us more insights and capabilities of checking, control, learning, optimizing, and eventually automating, if you want, in a more advanced view of mature version of the digital twin concept. So we have been studying digital twins since a while, since the West Cambridge Digital Twin Project, and we learned many lessons, and one of them is that sounds trivial, but you cannot start, developing a digital twin for representing everything that you can see in the physical and digital world as well. We need to have a purpose. So we decided to address this problem within the healthcare domain, which is, and especially in hospitals, which are social infrastructure where the use of the building or the facilities is very much related to their impact on the users, which are the patients, right? So any change on the management, on the operation of the building is actually impacting on the patients. Surprisingly, we don't know yet to what extent changes in the maintenance policies, operations of the physical assets are impacting directly on the patient. So for instance, we know that for bringing sample from one place to another of a laboratory in the hospital, you spend time, so you impact on the throughput, but you don't know what happens if you have to take the lift and the lift is down and you need to take the stairs. So there's no direct relations on that. So we put together this digital hospital project. It's a 2 years project funded by the NHS. So actually, Cambridge University Hospital. We are planning to extend it, but that's the first exploration of digital twin in the healthcare domain. It's divided in two parts. So there's one part on low-cost digitalization. There is an approach which is called shoestring, which we are using for finding off-the-shelf technologies which can improve the data collection process, automation of the processing in the healthcare domain. And there is a digital twin strand. There is a digital twin work stream. The aims are to identify the requirement for the digitization of hospitals, leverage data science and process modeling techniques to impact on the hospital operation and the patient health eventually. And so we are aiming at developing a framework for digital twin in hospital at the end of that. Right, so the aim of this paper, this is a very initial study, so we've done some progress, of course, on that in the past year. But the aim of this paper is to identify the key variables that inform the opportunities for hospital digitization. It's concerning. Hospitals are digitized, but not that much. So when you go through the NHS, you want to have someone working on digitalization. So this will create a baseline for digital twin ideation and then development and implementation, as we are doing in a lab space in the Addenbrooke Hospital in Cambridge. So the hospital digitalization has a set of benefits, automated workflows, so you can think about, for instance, the patient scheduling, treatment, and so on, remote monitoring, both of the patients and the assets and processes within the hospital, improved communication, of course. You've got data transparency. You can communicate better between consultants or between the operation of the building and the core processes, which is the sort of consultancy processes of the doctors. You enhance the data analytics capabilities, and you impact on cost reduction. So what are the research questions? when we start working on this project, hospitals are very complex facilities in which there are a lot of core ancillary processes. Asset management and operations are very they are very extensive in terms of delivery services. And of course, the focus is on the patient, right? So it's one of those typical cases in which the patient has the most, let's say, well, the core business has the most important place in the budget allocation. And then when you come to the end, you say, okay, yes, then I have the budget for the hospital facilities management. So we are trying to look at from a different perspective at the facilities management and operation of the hospital, starting with the impact that these dynamics could have on the patient. So what are the key challenges for the ideation of hospital digital twins that can capture, use data for analytics and enable efficient asset data and human data interaction? And what are the common parameters that can be used for clustering these processes? So we start with describing what's happening in a hospital facility. So we identify these 4, let's say, pillars, which are the fabrics of the building itself, the processes of what happens in the building or for the building, for operating and maintain the building, or the equipment, the resources, that's again equipment and human resources, IT, operation technologies, and the supply chain, which is a critical bit in the digitization of our hospitals. And yeah, here you can see some examples. For instance, the input is everything which is coming into a hospital project, can be biological samples, materials. Output is everything which is processed and delivered to the final stage of the service. Constraints is what limit those sort of transformation, and so on. So let's look at an example at the reception stage of the histopathology laboratory of the Addenbrooke Hospital. The histopathology lab or department is the one which take samples from human beings and start processing those samples to assess, for instance, if it's cancer, if it's not cancer, and eventually gives the patient the diagnosis of the potential problem, which is spotted through a biopsy or the collection of a specimen from the patient. So we are currently working with both consultants on process management and operations management managers. So the first step was mapping the process of the histopathology department, which is very much similar to a disassembly process. So the sample is received, is cut up, is divided into thinner slices, is stained, and then is assessed by the pathologist. So it's very much sort of manufacturing sort of process. And once we identify those parameters, so those group of variables and the variables for each stage of the process, we start looking at what are the digital, available digital solutions and opportunities for the digitization of each of those parameters within each phase of the process, which is in this case the histopathology process. And what we identified, thanks to the we applied the shoestring approach. That's another strand of research, but in a nutshell, basically, it's an approach which, from a strong requirement engineering phase, identified the off-the-shelf technologies. There are many that we can use for improving, in this case, processes, but also asset monitoring within several domains. It's been applied to the manufacturing. We're applying it to the healthcare domain. And we identify a set of technologies which can deliver 3 kind of benefits. The first one is a process level benefit, so you understand better what's happening in the process. You pull data from existing systems and you enrich the data describing the single process through, for instance, IoT technologies or job tracking technologies like barcode scanners. Okay. And so this enables a more granular, more detailed description of the process of the phases of the histopathology process. There is a process interrelationship sort of benefits. If you know better each single process within the hospital, that means that you can also spot the overlappings and in the interrelations. And that's something that we are actually studying, connecting asset, facilities management, operations, and patient health. So this is, I would say, the most interesting maybe research bit. And there is a simulation level. So once you got clear these sort of interrelations, you can also predict how they work in the future if you're changing their input parameters. This is just a summary of some tools that we're pulling together. So we start with a discrete event simulation of the histopathology process. We had some very pragmatic issues as how does the staffing allocation impacts on the throughput, so the number of sample processed in the histopathology. And we start building not only that, but also we start modeling the building to understand what are the spatial interrelations between the space function of the lab, and we start building simulation scenarios. The one that you can see at the left is the very initial scope of the digital twin framework in hospitals, where you can see again the four strands of fabric processes, some sort of KPIs that can be calculated and used in an interdisciplinary way for assessing the performance of those processes to impact on the patient health. Many challenges. I'm late, so I'll try to focus on the most interesting ones. Data security and privacy. We are not in a situation in which we can pull data out of the system of the hospital and use it for any other purpose, but something which is very specific in the NHS. We're working with patient data. This is the focus. This is the hub, I would say, that is used for connecting other sort of data in the process optimization. So we need to be very careful in how we implement the systems, how data is handled, and data governance is another issue. There are underpinning problems like the one that we're seeing in other several digital twin projects. There is definitely a data modeling and interoperability issue. Systems don't communicate, and the integration with the legacy technologies. Right, so conclusion, so final remarks and next development. So we developed the DES, so discrete event simulation of this disassembly process. We can explain and we can study the dynamics in the hospital more effectively than before. Basically, most of the processes are paper-based. The data collection is paper-based. Now it's more digitized. And we're working on a BIM, Bracket GIS, don't make question on that because I haven't developed it, DES strategy for understanding how the space and function is actually impacting on the simulation of the operation of the lab. We are deploying the digital technologies for increasing the data collection capabilities, granularity, detail in the process monitoring and job tracking towards the definition of the hospital digital twin. I'm late, as you know, and but I'm also chairing, so we have time for a question to the presenter.